Now our next topic is motion of a vehicles on a banked road. This is related to the earlier topic. This is not a plain circular path, plain circular road. It is a banked road. Banked means we have raised the outer portion of this circular path above the inner edge. This is your outer edge. This is our outer edge. This is the inner edge. This is the level road. Level road means this is the horizontal road, horizontal ground, and we have raised the outer edge from the inner edge by an angle of theta. This is the angle theta. So we can say that it is a banked road. So we generally banked the road so that there is a wear and tear between the tires and the road, because there is a heavy losses when there is wear and tear of the vehicle's tires, because these tires are very costly. Also, so if I increase the velocity of the vehicles at the circular turning, we should have raised the outer portions from the inner portions by an angle of theta. In this way, we can have two advantages of this one. So this is our vehicle and this is our horizontal ground. So its weight is acting vertically downwards. Its weight is mg, which is acting vertically downward direction, and a normal reaction. Our vehicle is placed on this inclined path. This is an inclined path. It makes an angle theta with the horizontal ground. So the normal reactions would be normally there should be normal reactions which always be normal to this inclined path. So this is the normal reactions of this inclined path R. So this is theta. From the geometry, this angle comes out theta. This angle will be theta because the angles between two perpendicular. If I make it perpendicular on this line, this is perpendicular on this inclined path, and this is the perpendicular on this horizontal path. Angle between them is theta. Therefore, angle between their normal is also theta. Therefore, the angle becomes, this will be theta. So we have to make the component of this normal reactions on this banked path in vertical directions. It will be, if I resolve this r cos theta vertically directions, and another component of this normal reaction which is r sin theta. We know that these two tires, these tires of this vehicles is in direct contact with this ground. So there is a frictional forces. Normally the vehicles have a tendency to go the outward direction. Whenever you increase the velocity of these vehicles, the vehicles have the tendency to move outward directions. It will excrete outward directions, so the frictions definitely act in inward directions. So suppose the resultant frictions between the tires and the ground is acting along these ones, and this is the center of this circular path. So net frictional force will be F. So we have to make a component of these frictions along this horizontal, along the vertical directions. So along this F, if I resolve these frictions along horizontal direction, it will be F cos theta, and vertically direction it will be F sin theta. Therefore, if this is our frictional force along this one, and it makes an angle theta with the ground theta, so we have to resolve this frictional force F cos theta. It will be theta, and F cos theta will be acting horizontal directions, and F sin theta will act vertically downward direction. Therefore this will be acting vertical direction. So we have in vertical directions, we know that frictional force is equal to coefficient of friction multiplied the normal reaction. R is your normal reaction. So we have resolved this normal reactions in horizontal and vertical directions. Normal reactions. Since there is no motion vertical direction, so resultant force along the vertical direction should be 0. Therefore, r cos theta, there are two components. One component of r acting vertically downward direction, another component the frictions which act vertically downward directions. It will be f sin theta. F sin theta will act vertically downward direction, and f cos theta should act along this one. So from these equations, net resultant force upward direction is equal to net resultant force in downward direction. Therefore, r cos theta, which is acting vertically upwards, will balance mg, which is acting downward direction, mg plus the component of friction acting downward direction, which will be f sin theta. This will be our first equations. And now in second equation, we can make some arrangement of this one. R cos theta from here minus f sin theta. R cos theta minus f sin theta will be mg. Now this is our equation number first. Now another component of the normal reactions are and the frictional coefficient. The frictional force will provide the resultant centripetal force. We know that whenever a vehicle making a circular path, there should be a centripetal force. The centripetal force, not a natural forces. This centripetal force provided by other natural forces. Here the natural forces is the component of frictions and the component of the normal reactions in the horizontal directions toward the center of the circles. Therefore, the centripetal force will be provided by the component of frictions F, which is acting along these directions, F cos theta, plus the component of R, which is acting horizontal direction toward the center of the circles, which is R sin theta. Therefore, F cos theta plus R sin theta will provide the resultant centripetal force. We know the centripetal force is equal to mv square divided by R. If the radius of this circular path is r and v the velocity of the vehicle at this turning point and m is the mass of this one, so this will be our equation number second. If I divide equation number second by first and then making some rearrangement, I will get the maximum velocity at the circular turnings, which will overcome the wear and tear of the tire due to the frictional force. Once again, to recapitalize again, so your frictional force acting along this one, because your vehicle going outward direction, friction will act just opposite of the motion. So friction along this ones, and this is your ground. This inclined plane make an angle theta with the ground theta. Therefore, if I resolve the frictions in horizontal vertical directions, this is theta and this is also theta. These two angles will be alternate interior angles, and f cos theta along this one and f sin theta along this one. F sin theta will overcome r cos theta component, and f cos theta will contribute toward the centripetal force, and the component of r is r along vertical directions, r cos theta, along this one r sin theta. So this r sin theta and this f cos theta will provide the required centripetal force. Now that centripetal force will be mv square upon r. Now if I divide second by first, I will be able to get the required velocity of this vehicles at this circular turnings. Now if I divide equation number second by first, I will be able to get second upon first, also putting f equal to mu r. In place of f, if I replace with mu r, so I will be able to get the velocities. Now r cos theta, put the value of f, which is mu r, minus mu r sin theta is equal to mg. Now second equations, f cos theta plus r sin theta is equal to mv square divided by r. Now taking the ratio of these ones, therefore mu r cos theta plus r sin theta divided by r cos theta minus mu r sin theta divided by mg. If you simplify this ones, it will becomes v square upon rg, and taken r is taken out, r is taken out. So finally it becomes mu cos theta plus sin theta divided by cos theta minus mu sin theta is equal to v square divided by rg. Now if I divide the whole equations, if you divide numerator and denominator by cos theta by dividing numerator and cos theta, numerator and denominator by cos theta, I will get the simplified format of this maximum velocity of the vehicle at the banked road. Now the simplified formula becomes, if I divide the numerators and denominator by cos theta, I will get mu plus sin theta divided by cos theta upon 1 minus mu sin theta divided by cos theta, and right hand side it will be v square upon rg. Now you know that sin theta upon cos theta will be tan theta. Now this formula becomes mu plus tan theta divided by 1 minus mu tan theta, and is equal to v square divided by rg. Now taken rg toward the left hand side, so it will become, so now rg times mu plus tan theta divided by 1 minus mu tan theta, and this value becomes now v square. If you taken the square root both the side, you will be able to get the maximum velocity of these vehicles. Therefore v will be rg times mu plus tan theta divided by 1 minus mu tan theta. So this is the required formula for a vehicles in a banked road,